Okay, the stream should be started again. Let's go. I think it worked, guys. I'm gonna keep going with these questions. There's no way you're doing English. Okay, so basically I changed that to T. And I know that it's gonna be minus 9.8 brackets 1 plus 2.8, which was the initial velocity, so like the y-intercept. So it's just gonna be minus 9.8 plus 2.8, which is oh sorry, I got distracted, which is minus 7. And 7 meters minus 1. Okay, and then yeah, basically you do need to say like what the equation for acceleration is, which is minus 9.8, and then you have to basically say you integrate it. So like, I guess instead of doing what I did, which is kind of messy, just ignore that and say let me think. Say something like, so state that the function for acceleration is minus 9.8 because it gives us the gradient, and acceleration is the gradient of velocity, and then go v brackets t is equal to minus 9.8 t plus c, and we know c because they gave it to us. So that's what I did, and then I scribbled it off because it's unnecessary. Have a look at my live stream. Have a look at how I fully. It's too late to turn back. Hold on, let me just talk with my dad real quick. Oh, I can't stop it. Wait, I'll be back.
Conseguiu 7. Só 7. Contando Samuel, tu e eu. E o Shane que não vai agora, não.
You didn't use the integration sign. You didn't close it off either.
Só que no céu que
ia precisar depois, deu não?
Ah, não ia, daí ninguém estava vindo livros ali.
Fala pra ele, eu posso perguntar pra mais gente, é que tu não me pediu, tu só falou pegar uns 8. Eu sei que tu queria uns 8, 7. Okay guys, I'm back. I just need to sort out the futsal stuff. I did, look, it's scribbled off. I'm telling you, I can't turn back on this. It's here. It's...
You should always use the integration sign.
I did, and then I scribbled it off.
Why did you scribble it out?
It's too complicated.
It's not complicated. You do like that long thing and then you close it off by dx or whatever it is.
Yeah, that's what I did. Wait, are you meant to close it off by dx plus c or no?
No, you close it off with dx.
Okay, so guys, Honey's being annoying and she wants us to do the integration sign, but if you don't want to, don't. So,
You should do the integration sign.
whatever. I'm just gonna write it here at the bottom.
We won't go back to my
It's like this, right, Honey? Check the stream.
Oh, yo, wait.
Is it plus dx? Or is it dx plus c? Or...
No. You're not doing it properly. Stop telling people what to do if you can't do it properly yourself.
I was just... Hey! You're the only one watching the stream. Also, you're the one telling me to do this. I am doing it properly.
you just do dx and
That's what I did.
yeah.
Oh,
Yeah,
you just told me I was doing it wrong. You just told me I was doing it wrong. I'm
No,
not.
because it's lagging.
Okay, then take a minute before you speak, I guess. It's so laggy. Okay.
Yeah,
Is that fine? Is that fine? Is that fine for you?
I would put brackets.
Around?
Just
Around.
actually, okay, what I would do is dt equals integration sign
Yeah.
at
Oh, yeah.
so in brackets, and then dx, and then the next step I would write this, and then the next step I would write the integrated version of it. Because that's more like communicating what you're doing, because if the marker sees only this part, they might be like, where did you get that number from? Did you look at another person's paper and do it? Blah, blah, blah.
Sure. So, brackets what? Brackets A, brackets T, or?
AT. Actually, you don't need to do brackets when you're writing the AT part.
You can. What do you mean?
Equals.
Yeah, my bad. I forgot that. I forgot that.
AT.
Like, what do you mean AT? Like A brackets T, or?
Yeah, A brackets.
Oh no, my GoPro disconnected. let's go, we're back. Okay, that's, hopefully I can just finish it with that. So as Honey said, this is the right answer. This bit here, and obviously, so that's our working, and then our actual answer is here. Okay, next question. The diver hits the water at a velocity of minus 22.68, so we know that v is going to be equal to that. Negative indicate that he's going down. Okay, so we know he jumped off a cliff and then he landed in the water, so he would have done like a parabola thing, because, oh yeah, it shows on the diagram as well. So he moved in a parabola. We have the equation for how he moved from the previous question. Find the maximum height above the water. Okay, so the height is gonna be the, it's like distance, so it's gonna be, how do I explain it again? We've got to find like h, I guess, h in respect to t, and so we go like this. So it goes d, or in this case h, and then it goes, so distance, velocity, acceleration. So acceleration is the gradient of, what's a good thing for gradient? I don't know. Gradient of velocity, and velocity is the gradient of distance or height. So if we have the equation for v, we're gonna want to find the equation for h as well. So, but I guess the first thing we have to do is we have to find what is the time when the diver hits the water, right? So we're just gonna sub in this value for wait, what did it say here? What was that one question thing? Let's see. Okay, so I'm just gonna write that down as well, like h t is just gonna be equal to anti-differentiation again, integration of v in respect to t dx. So if we put that in there, it's gonna be, so where's our equation for that? It's in the previous question, so I'm just gonna look at it there. Oh no, it's not, sorry, it's in our answers. So the previous one for velocity was this, minus 9.8 t. So we're gonna anti-differentiate that. What we're gonna do is we're gonna add 1 to the t and divide that by 2. So minus 9.8 t squared divided by 2 plus 2.8 t, yeah, 2.8 t plus c. Okay, and because we have that, we can find c. Oh, we can find c by just going, so it gives us the time where it gives us the velocity of when they hit the water, right? And we can say that the water is at height 0 because like it's the bottom of their fall. So because we're looking for the maximum height above the water, so water is 0. Water is the ground in this situation. So we're just gonna go, we're gonna find out at what t value did he hit the water, and we're gonna do that. We're gonna do that by setting it to, so we're gonna go v t, oh not again, okay, I'm giving up on, okay, it turned off again. I'm just gonna give up, but basically I'm gonna explain the answer, and if anybody actually ever watches this, just ask me for it. So what we're gonna do is we're gonna find t when he hit the water by setting v brackets t, so the velocity, to what they gave us, which was minus 22.68, and then just use algebra to find out what t equals, and it's going to be 2.6 seconds. So when the diver hits the water at 2.6 seconds, and then and then in the h, in the height function, we're gonna do height is equal to 0 because the water is at 0, and the t value is at 2.6 because that's when he hits the water, and then sub all that in and then find c using algebra. So we're gonna get 0 equals minus 9.8 over 2 brackets 2.6 squared plus 2.8 brackets 2.6 plus c, and then just use algebra to find c. So c is gonna be equal to 25.84. You can just you can put on your calculator. So we find out that, so that's from the cliff, right? So the cliff is gonna be that height, 25.84 meters above the water. And now we need to find out when the top of the jump is. So we find the max, right? The top at a turning point. And so in the turning point is when the gradient is equal to 0. So what we're gonna do is we're gonna set the gradient of the height function, which is the velocity function, so vt equal to 0. So 0 equals minus 9.8 t plus 2.8, and then just find out what t equals, which is gonna be 2.8 over 9.8, which is 0.29 seconds, and then plug that 0.29 into, in the height equation you can plug in the 25.84, which was the cliff height, so the y-intercept or the t-intercept, into the end, into c. So the height equation is now minus 9.8 over 2 t squared plus 2.8 t plus 25.84, and then plug in the 0.29 seconds, which was when he reached the top of his dive, into that equation, and you're gonna get 26.24 meters, which is the maximum height over the water. So yeah, that's it. I'm sorry I couldn't record it. It's my GoPro's